Gravity is the force that keeps the planets in orbit and pulls apples off trees. Isaac Newton had a theory of gravity which was later superseded by Albert Einstein's general relativity. Unfortunately, relativity has flaws, so gravity is a mystery for the physics community at the moment. In this video I explain where Einstein went wrong, describe the correct way to measure relevant phenomena, and outline the relationship between gravity and electromagnetism. I start by describing the current accepted view. Newton described gravity as a universal force. Every object with mass pulls every other massive object. He gave the formula F equals G, m1 times m2, over r squared, where F is the force between the masses, G is the gravitational constant, m is the mass of an object and r is the distance between them. In other words, the attractive force between objects increases when the distance between them decreases. The exact force can be calculated if the exact masses and exact distances can be measured. Then Einstein came along and said it isn't quite exact. In general relativity, each object distorts space and time in proportion to its mass. It is this distortion that makes objects move towards each other, and when you calculate by exactly how much you will be closer with Einstein's equations than with Newton's. But this distortion also makes clocks run slow and long things short. If you make a couple of identical clocks and put one on a mountain, it will run quicker than the clock left at sea level. The relativistic explanation is not that gravity slows things, but that gravity slows time. This explanation confuses the concepts of space and time with the way they are measured. In order to understand what is going on, we need to look closely at how those spaces and times are measured. Einstein took the speed of light to be a fundamental constant, and used it to measure space and time. For him, space means space is measured with light, and time is timings measured with light. So when you hear that time slows down, what that means is light slows down, where time is measured with light. When they say space contracts, what they should say is that spaces they measure with light are smaller, because slower light covers shorter distances. When space-time curves, that is because curving light has been used to define a straight line. Assume for the moment that the speed of light is not constant. Assume that the strength of the gravitational field determines light speed, that light slows down as gravity increases. A ray of light will speed up as it travels out from a gravitational source. It will then slow down again as it approaches a second massive object. If you use the speed of light to measure the distance between two objects, then you need to take this speeding up and slowing down into account. If you do that, then Newton's formula is precise. Space does not need to contract to account for these measurements. You could use the concept of relativistic time dilation to keep a GPS satellite accurate, but you could be just as accurate by realizing electromagnetic signal speed changes with height. We know that light changes speed in lenses, and that is what causes it to refract. If it is true that light changes speed in a vacuum when traveling past massive bodies, then stellar objects should make lenses. So gravitational lensing is exactly what we would expect if light speed is determined by gravitational field strength. Refraction is the curving of a wave when it changes speed. If you can't admit that light is curving, then you must make the ridiculous statement that light is traveling in a straight line in curved space-time. Why would anyone assume that the speed of light is constant? You would measure that to be the case if you measured it against itself. For example, I am as tall as me. When I was 2, I was as tall as me. Therefore I never grow. We know that light travels a large number of meters per second, and a meter is a small fraction of the distance light travels in a second. So light travels at a multiple of a fraction of the distance it travels in a second, per second. That is a circular definition. Light goes as far as it does a second every second. Measuring light speed as constant is a bit like measuring the Earth as fixed in place. In order to measure speed or anything else, you need something to measure against. Measurements are comparisons. Light speed is only constant when compared to itself. So despite what you may have heard, constant light speed is not a fundamental fact of the universe, just one way to measure spaces and times. All of the observations that support Einstein's general relativity can be accounted for, using Newton's gravity, and the hypothesis that gravity determines the rate of electromagnetic propagation. So a relationship between gravity and the electromagnetic field is, gravity determines the rate that electromagnetic things happen. So we have two theories that can account for every observation, but relativity is provably wrong. The new theory states that as mass increases, gravity increases, so electromagnetic interactions slow down. When mass gets extreme, the speed of light, being an electromagnetic phenomenon, may slow to a stop. This is a testable prediction about physical things. If you insist that the speed of light is constant, and you try to measure spaces and times against stopped light, you will conclude that space has shrunk to nothing, and time stretches to infinity. That is a logical paradox, and is one of the ways to prove general relativity is wrong. Therefore, gravity cannot be described in terms of general relativity. Instead, gravity might be described as the force that determines the rate of other forces' interactions.